Okay, class, so this lesson is on a little bit more review on functions and the connection between functions and relations. So let's look at this. This statement right here says that a function is like a machine. And what I want you guys to do for this is just really pay attention to this lesson. You can take notes if you want to, but it's not mandatory. Alright, so if we look at it as a machine, let's put a machine up there. What's a machine that everybody knows? It's a Coke machine. So if we have a Coke machine, and well, how do we get a Coke out of it? Well, first thing we need is some money. So let's put a couple quarters here, and let's say that this Coke machine costs 50 cents for Coca-Cola. So we can say that these quarters here, well, this is going to be my input. And what happens when I put these 2 quarters into my Coke machine? I get my output, which is a Coke. So my input is the quarters and my output is the Coke. Okay, another way to look at that is that the independent variables, my input, remember we said that the way to memorize that is they both have in to start with. So the independent variable is the input, the dependent variable is the output. And that makes sense in this scenario. Now let's relate this to math. So we're talking about what is a function. Remember last class we also defined a relationship. Well, it turns out that a function is just a special kind of relationship. So let's look down here and let's look at some examples of what some functions are. So we have an age example. So if you took all the people in the class and you arranged their age and from the people in the class, so you had a dependent and independent variable, well, these are functions. But we'll see that they're not reversible. Okay, so what is a function? An easy way to state what a function is just say that it's a special relationship such that the inputs, there's exactly a one-to-one correspondence with the outputs. So you only have a one-to-one correspondence. So this one-to-one is very important. That's how you're going to remember whether or not this relationship is a function or not. Okay, so this pairing, let's take our example from, we have the person and the height. Well, if you look at each person in the class, each person has a one-to-one correspondence with the height. Everybody in the class has a unique height. So each independent has exactly one dependent. Okay, now if you reverse that, it doesn't make sense. Every height doesn't just have one person. There can be many people that have the same height. So each height does not correspond to exactly one person. So height and person, it's a relationship, but it's not a function. Okay, so height to person is not a function because there's many to one. I mean, we could say that 3 people in the class, for example, Tom, Mary, and Bob, we can say that they're all 5'8". So if they're all 5'8", then it's not. There's no one-to-one correspondence here. We can't determine just because someone's 5'8" that it's Tom, because it could be Mary or Bob. So this is not a function. It's still a relation though. So the big thing to point out here is that my relationships have to be one-to-one. A special relation such that for all the values of x there exists one and only one y value. And again, we can say that the x is the independent and the y value is the dependent. Okay, so with our relations, a function just falls in this as a special type of relation. So a function, every function is a relation, but not all relations are functions. So if we look at this, let's put the independent, and we state that the independent, or the domain, on our xy graphs we primarily use x as our independent variable. So remember x as being our independent, and associate x with domain. So x and domain. Y is going to be associated with our dependent variable. That's our output, and this is our range. Okay, let's look at an example here. We have these sets of relations. So if you look at this, this first set of ordered pairs, we have 2, 3, 4, 5, and 5, 6. Well, each one that comes first, these are our independent variables. Well, here we can see that none of our independent variables are repeating, so there's no repeats. So therefore, since each one is independent and each one is different, well, it has a one-to-one correspondence already. So we can say already that this is a function. So yes, it is a function. Now let's look at this one. So we have 2, we have 4, and we have 5. Again, we have no repeats. So the same thing here goes. We have no repeats. Therefore, yes, again, it is a function. Now last one, if we come down here, well, we have 2, and we have 2, and we have 5 for our independent variables. So therefore 2, well, in this case 2 is associated with the 3. And in this case, 2 is associated with the 5. So therefore, it's not one-to-one. So this is not a function. No, it's not a function. So that's how you can tell whether or not something is a function or not. Okay, we're going to be going more in depth with this, and I'm going to give you guys harder example problems. So they'll be posted. And make sure that you practice these. The ones in the book are quite a bit harder, but I'll make sure that we post these on the blog.